Hi, I'm Liz from Arca Space, and on this week's episode, we'll be showing you some of the logistics that are going into preparing for the Demonstrator 3 launch.
The plan for today is to continue working on the engine mold, to cast the mechanical structure this week, and to prepare the tank mold. We have a meeting with Spaceport America. We have a lot of teleconferences with NASA and a branch of the armed forces. We also need to solve a lot of logistical problems related to the procurement of the fuel for the rocket, accommodation for the team members, transportation for the hardware, and it's going to be a very, very busy week.
This week we calibrated one of our IMUs for the Demonstrator 3 rocket. I also had Liz help me build a circuit for our temperature sensors, and we also checked the voltage of some of our batteries as they've been in storage for a little while. We also started implementation of our ground control station, and hopefully we'll have that up and running very soon.
We are going now to Spaceport America offices here in town in Las Cruces to talk with their team about logistics and flight operations for the Demonstrator 3 rocket. We'll let you know what we discussed and the decisions that were taken immediately after the meeting. This is based on the previous Demonstrator rockets that we launched. We are going to provide you with the data for the previous rockets. Here is a good comparison. For the Haas rocket, we talked with those people from Houston, and they are also supplying 90%. But for now, we don't need it.
Okay.
For now, we need just 70%.
Okay.
In this case, we are going to use only 2 tons of hydrogen peroxide, so it's significantly lighter. Since we are going to put the smaller quantity of hydrogen peroxide in the tank, we are going to have a bigger volume of gas. So everything in the range of a normal suborbital rocket that is going to 100 kilometers. We have here the basic pre-launch and launch schedule. We propose to start with 7 days in advance of the launch day. The launch pad is going to look something like this. We are going to use the previous design for the Demonstrator rocket, but this time is bigger. The way we are going to integrate the rocket, it's going to be articulated, and we put the rocket on the launch pad and then lift with a crane. Have there the test stand, put the rocket on the test stand as it is.
So is that going to be a full duration burn, or is it going to be
I would say not.
Okay.
I would say not. Maybe, I don't know, 20-30 seconds just to measure the thrust and check the functionality of the whole system end to end, and that's it. More in detail into everything.
So the fin assembly is a separate composite structure? Is that how you're doing it?
Yes,
Okay.
and it's going to be attached on the engine.
Okay.
We decided to place the main avionics between the engine and the tank, and the backup avionics in the nose.
All right. White Sands could want a radar transponder. If we can come up with a mission model that it doesn't land on their ground space, then chances are we will not have it.
No.
There are benefits.
Yes.
Because you can get a very accurate trajectory.
Yes. I think we are going to talk with they contacted us last Friday, and they are interested about this launch because of the Aerospike.
So my guess is that They just want to see one fly.
Yeah.
You know, nobody's ever flown one to space. If they could assist with a safety analysis, a trajectory analysis, I think that might go a long way toward getting White Sands to get on board easily and quickly. So
Okay.
a really quick turnaround.
Yeah. Okay, that would be great. So we finished the meeting with the Spaceport team, and the meeting was very productive. We talked a lot about logistics, the incoming preparations for launch, storage of hydrogen peroxide at Spaceport, and involvement of White Sands missile range for safety analysis for the vehicle, and also the radar and visible spectrum tracking. One of the things that we need to solve with our rocket is the fact that it's stealthy, and it's very difficult to track it on the radar, but we are going to solve that by putting metallic structure in the composite material that we are going to use for the rocket. We are heading back to our facility, and we are a little bit in a hurry because in 15 minutes we have a teleconference with a branch of the armed forces. They are very interested in the Aerospike technology and the Demonstrator 3 rocket flight that is going to happen in short time. And we can't give you the details for now, but there is a lot of interest from that area for our technology, for the Aerospike technology, and we hope to have a new, very important partner soon.
That's it for this week's episode. Please leave your questions in the comments section, and stay tuned for next week's episode, where we'll be showing you the final mechanical structure for the Aerospike engine. See you next time on Flight of the Aerospike.